Scott Wessex Blades with a bit of a, I wouldn't say a rant, I don't even know how to sort of term this sort of video. It could be a grind off or something, but it's a sort of defense of knife makers when it comes to keyboard warriors with the inability to use Google. Where I noticed yesterday there was a cool YouTube channel, and the format of the YouTube channel was he made something, he documented the thing, every step of the way he was going, more or less, well shot, well lit, well edited, in focus, you know, a good effort, from flat stock through to the finished knife. And then he showed it. You know, you only get the keyboard warriors having a go at it. And let's not forget that that's the format of that person making his videos. So he's not narrating over the top. He wasn't really putting loads of titles and descriptions. That's all he's doing. He's making it, he's probably selling it, and while we're at it, off his own back, okay, he's doing an entertaining video as well that's well shot, well edited, well lit, and all the rest of it. So you'd have thought you'd have had some appreciative comments like, thanks for sharing this with me and all the rest of it. But what you get is, unfortunately, okay. So what I thought I'd do is address what the adversarial comments were with this one person, but also to share with you why I do one certain section of a knife making build the way I do it, okay, based on, I was in engineering-ish, and I was in manufacturing-ish, and I was in education-ish for about 25 years, nearly 50 now. So things I've picked up along the way. I'm not Isambard Kingdom Brunel, I'm not Dyson, I'm not Elon Musk, okay, but I've picked up things along the way and thought, I like that, I won't be doing it that way because that had problems, and gradually from talking to people and sharing, you end up with. But what I don't do, if I can help it, is come up with some adversarial challenge in order to, you know, drag out of someone the holy grail of information that apparently I'm lacking in, which is what this comment was. So the comments were, in, you know, one person was, why do you drill so many holes? This is in the handle, drilling holes. I don't understand the chamfering. When it's covered with epoxy and scales, anyway, ABS mastersmiths rarely, if ever, do any of these wacky things. Why drill all the holes? If the best knife makers do not do these things, why do you? Nice comment. Just what you want when you put all that effort in. You know, when you've done a video, shot it, and some keyboard ninjas having a go at you. Literally trying to extract information when all you need to do is, why is he drilling so many holes? Okay. Google. Why do knife makers drill holes in handles? And all of a sudden they come up with all the information. Why do knife makers chamfer holes? Google. Okay. Anyway, why I do what I do when I do what I do. This is what I know. So, why do you drill so many holes? So, he was, you know, you could make a knife using only the holes, that are meant for pins. That will make a strong handle, would you say, because of the section of the steel. Okay, it would be very stout. However, it may be quite heavy in terms of balance. That means for all the difference 10-15 grams of making a hand. Some people, if you can imagine, if you're carving for hours on end, it would make an advantage if it was as heavy at the blade end as it was in the handle end. So, being that there's stock removed on the blade, and being that there's probably more steel there because you haven't removed that area there and you haven't removed all of that steel, you only took a few little scoops out there and that, plus added the weight of the pins, plus added the weight of the liners, plus added the weight of the scales, plus added the weight of the epoxy, okay, it could be handle heavy. I'm 17.5 stone, probably wouldn't make much difference to me. I don't carve for hours on end, probably wouldn't make much difference to me. Having a blade heavy handle with this model, and you're going to batten it, swear word, batten it through wood anyway, means you want it handled down as you're taking it. There's so many reasons, it doesn't make any difference. My knife design for that one is like that. Why? Because it's simple. But why would you want to drill so many holes? So, balance. So, if you had a piece of steel like that, and you've made your wood lorry shape like that, and it gradually goes down to there, and your wood lore comes up and does that as your wood lore. Okay, in terms of, you've took all of that steel out there, you've took all of that steel out there, you've removed half of the steel on the bevel. By the time that you've took all this out as well, and then done your 3 holes, oops, sorry, it's not a wood lore clone, because a wood lore clone does that. See how my design is not a wood lore already. My choice was to have them equidistant from scale at one end, center, pommel section. A wood lore has a Corby pin there, ish, or a Loveless bolt, a Loveless bolt at the other end, and then closer to the rear Loveless or Corby would be a lanyard tube. I don't make them like that. I've come away from that design. That's why I've done the way I've done it, the way I've done it. So, why do you drill so many holes? Maybe that's the way he wants to do it. Balance initially. So he's done all that, and then you add on the thing. There's a possibility that the handle could in fact shift the balance point to maybe there. So what could happen is they drill a hole there and a hole there, just to remove a little bit of steel, a little bit of weight, just to eke back the balance point and push it a little bit that way. How about that? How about a knife maker made a choice to drill a few holes? Okay. Why additional holes? Why so many holes? If you had a handle, I'm looking at a plan view, okay? There's the blade from above. You will put on a liner, scales, a liner, and scales. All that's connecting him to him is a pin or lanyard tube with the glue either side of the lanyard tube. If you had a hole here, the glue would also be from there down inside the hole and alongside underneath there, connecting this side through the handle, bracing and connecting that to the other side. It's called through gluing. There's 2 reasons. So I'm using the epoxy to actually connect one side to the other with more adhesion than solely the epoxy on the outside of a lanyard tube, a Loveless bolt or a Corby, or a Loveless bolt and a Corby. So this is more connected to that. It's more together. There's glue all the way through. The other thing you can do is on your handle, obviously I'm drawing this all backwards. There's your Woody McWoody. You can go on a idler wheel and you can scallop out sort of half moon section on both sides. Not much, just enough. And that allows then the glue to join this hole to that hole, through that hole, through this to that hole, through that to that hole. It's even more connected, and you've got a well of glue that can go together when you squash it together with clamps. You're not squashing all the glue out. You're actually making use of the glue you've put in there, as opposed to getting squeezed out. You're actually going to make use of it. And epoxy is generally lighter than steel. So you've reduced weight. So your section of your blade is now, looks like this. And you've gained the loss of weight. You've took out steel and you've put epoxy in the handle. So you get aid in balance. So why do you drill so many holes? Balance, through gluing. You could do a choice of doing a fuller effect on within the handle, more through gluing. Okay. Master bladesmiths rarely, if ever, do any of these whacking. Generally speaking, a lot of master bladesmiths do stick tangs for balance. They're that good, and I bow to their general superiority. A lot of the times, their blades are that good. Okay, they'll make them like that, and they'll put one pin there. It won't be as big as that. They'll put one pin there. And if a master bladesmith wants to do that, he can carry on. Okay, I'm a knife maker. I don't deal in stick tangs. Okay, there's a lot of things that I will use a full tang for strength, whereas a master bladesmith, he's got it way down. His removal of the material for the handle, if he puts a guard on, if he puts a bolster on, however he pings the end over, or whatever pommel he puts on, is going to be top quality. Master bladesmith could do that. But if he's forging it, he's not going to forge a full tang and then grind that down. He's going to forge it like that. If you're going to do stock removal, you wouldn't stock removal that. You want to remove the least amount possible. Who stock removes a knife of that profile? If you're going to stock remove, you'll do something like this, where you're only going to remove a little bit and a little bit, a little bit. Yeah? We wouldn't be making like that, generally speaking, in stock removal. That's a forging blade profile, because you're using as much steel as you possibly can, get as much blade as you can, while retaining a fair amount of steel within the handle for strength and rigidity. But also, he wants to be able to use the balance effect. So how much steel is not there compared with what was not there by stock removing and removing holes in the handle anyway? He's got the same theories going on, he's made it a completely different way. So the ABS Mastersmith, different knives, different ways of making. So what he has forgotten to ask is, you've drilled all the holes, right? And then why the chamfering? Why the chamfering? Well, first of all, he didn't ask, why didn't you ream it? Not ream it, ream it. So you drill a hole, okay? What you will have is probably a slight amount of scoring in it. Now, if you ream the hole out, you will finish the hole ever so slightly better. What we're trying to get down our holes, on our blade edges, handle edges, is a smooth finish, devoid of pits, cracks, or sharp corners. So if you've drilled the hole and you've drilled it really, really well, you're probably not going to have a reason to ream it. Okay, but if you've blasted through and your drill bit's a bit nasty, occasionally you'll get school marks in it. So to ream the hole, or just dress it out with a Dremel or something, just a little bit, will tidy up the hole away from what the drill bit, the starts at the beginning of the drill bit, has done, and the flute as it's gone down through. Doesn't always leave the most perfect finish. It's not really the end of the world if you've done it, but what we're trying to do is get a job better than if we hadn't considered it. The balance, the weight, and all the rest of it. What we're talking about now is pits, scratches, or sharp corners. We don't want something called stress propagators, or strength is going to be what's the word, the chance of having all the stresses and strains within a knife being used physically, having somewhere to start at. Okay, it's a riser, that's the word, a riser. So you've got a piece of steel like that. Now let's say it's going to be a pry bar and you're going to design a pry bar. You wouldn't put a thumping great hole in it like that, because you've got thinner sections there. Does that make sense? A pry bar's use would be daft if you've got huge holes there. What would be better is, for the same amount of steel lost, would be to add something like that, or something like that. More of a ellipse than a point. There we go. So still removed a fair amount of material, but you haven't got sharp corners. There was an airplane that was made, it's called a de Havilland Comet. The design of the Comet looks very much like a normal sort of plane that you get now. Alright? Very much. A bit dodgy Wessex. Alright? Very much like most planes are made now. Okay, very, very similar. However, when you had a look at the windows, 1949, the windows were really square. And all the stresses and strains of flying aircraft, it turned out that these corners weren't the best thing for it. So now you look at aircraft windows and they're more like that. Those theories, that idea, is what we're trying to get into knife making, if we can consider it. Okay, so what we try and get away from is having a sharp corner. What we're trying to get away from is pits, chips, just areas of cracks, anything like that. You can see how when I drew this one here, I've drawn a rounded section there. He hasn't made it like that. Okay? Well, it's just, I like having that like that. I like having that like that because when I glue my softwood guard on, I've got more area for the glue. It just wouldn't happen, alright? Softwood guard, cross grain, you know? Okay, wouldn't happen. So, you do a hole, if it had drill bit marks in it, you'd ream the drill bit marks out. And then, just in case you haven't got ever such a slight burr, you'd chamfer it. So your 45-degree tool will come in like that and just gently chamfer that off. Now you wouldn't chamfer it a ridiculous amount. So now we're looking at it side on. There's the steel. You would only chamfer just the littlest amount. Okay, you wouldn't chamfer it that amount because you want the rigidity for the pin to go through so that all this contact area here would stop the pin from moving. That makes sense. So you would chamfer it only a little. So why the chamfering? It just takes that nasty sharp corner off just ever so slightly, and that'll aid initially the pin. I actually chamfer the ends of my pins as well, so when you're gluing, the pin can rattle into the hole a lot happier. Plus you don't bicycle pump all the glue out of the hole because you've got a really square faced pin and a really square faced hole. By the fact that you've chamfered the hole and you've chamfered the pin, there's more chance that less glue comes out when you push the pins in from either direction. Does that make sense? Why chamfer? Takes the corners off, less glue push out. Happy days. You could have googled all of this. And where's the last one? Why drill all the holes? I.e. the volume of holes is basically for balance, but you not necessarily need to drill holes. My blades are lasered out, and then what I have to do after it's lasered out is Dremel all the way through here so that the start point of the laser initial blast, okay, when it comes round through and meets up with it, you end up with a little spike. I don't want that spike there, so I've Dremeled it all off neat and tidy. Plus, from the heat treat, I've took all the decarburized areas off, okay, so all of that is Dremeled. So it's all shiny inside and rounded corners, so I ain't got any starts. And then what I'll do is just before I be doing the gluing, I'll go onto the top roller and I'll just gently do this fuller's way sort of section across there just to connect everything up together again. So why if I took all that out here again? Wait, balance. Wait, balance. Okay, I've took weight out, but I haven't given myself square. I've not cut squares out, I've cut rounded things off, and even then I'll skim around the inside of the thing anyway with a Dremel, just taking any sharp edges or nicks or bucks or whatever, sort it all out there. It's good fun, isn't it? Anyway, one little thing about general knife making and making loads of holes. One thing, again, he never mentioned reaming, okay, and he never mentioned the gap between holes and the stock thickness. This is something that I mention occasionally when someone's done a lot of holes on a knife handle. So here's, let's say it goes round to there. There's a knife handle. Okay, someone's done a really chunky knife handle. You would have a lanyard hole, something like that. Okay, cool. Yeah, like it. Big thick lanyard. And then they drill for lightness. And they start putting random holes in. Like that. So what they've got is they've got a gap from there to there, and let's say that's 3mm from here to here, and they've got a gap there of 4mm, but they got a gap here of 2mm. They got a gap there of 1.5mm. They got a gap there of 1mm between one hole and another. And this one is 0.5 millimeter from the outside. Okay, what you don't want to do when you're is randomly drill holes. Okay, what I would say in your knife handle, if you're going to be drilling holes, get yourself a kydex pattern or a G10 pattern for whatever that knife handle is, and rationalize, think about, consider the thickness of the stock of the steel that you've got. So if your steel stock is 4mm, try not to have a gap of less than 6mm between your holes, just as an idea. So there's that there. You got a 4mm stock, and you got 4mm from the edge of that hole to there. So that isn't any weaker in terms of section that way than it is the thickness of it, 4mm, because that means that you've bought 4mm steel, okay, 4mm steel, but you've left 3mm to the edge of from your pommel end to your lanyard tube. So you've actually, well, why didn't you have 3mm steel? Because you've already made that thinner. It's just, to me, it's odd, all right? But at least he didn't put it a ruddy great thing like that and make that 1.5mm to the end of the steel. Granted, it's at the end, but why not have as thick a material in terms of your stock as the gap you have between one hole and the edge of the blade, or one hole and another hole? And let's say you want to do loads of holes to save weight, you could do three 8mm holes. That's a pin, that's a pin, that's a through glue in, and you could put some 4mm holes there. This allowing you to put a bolster on for two 4mm holes. That being 8mm, and then your back half scale has got your 4mm. You could pin that, your 4mm, an 8mm, and a lanyard. See how all that is braced, and you've not got, okay, much difference between what your thickness of your stock is and the gap between you sort of compromised it. If you end up putting a 4mm hole, but you put your 4mm hole up there and you've only got 2mm stock, you've left yourself hardly any scope for when you're cleaning your handle up afterwards. It's only ever going to get smaller, okay? So that 2mm gap that you've got there will end up as 1.5mm. 1.5mm is still, well, why'd you bother putting it in 4mm stock if you've just ground it down to next to nothing? And bear in mind, that's a brass pin maybe. That steel on top of there has got to cope with any stresses and strains, okay? Try and rationalize, try and think about the gaps between where you're doing your holes and not have, like, shoot yourself in the foot by having all of a sudden something too close to the edge or two holes too close together, and you've got more gap than you have actual steel, if that makes sense. So anyway, that's just my faults, ramblings, without trying to upset anybody. But yeah, just ideas. Why I make my handles the way I do is I either, get round to this one, either I've not done my pins exactly like a woodlore, because I don't want to do it exactly like a woodlore, okay? I don't use steel exactly like a woodlore. My heat treats are not exactly like a woodlore, okay? I use ball bearing steel, not 01. My pins are equidistant, not one at one end, one at the other end, and then very close to that is the lanyard pin. My 52-100 has a partial bayonet heat treat, okay? I don't do everything bog standard exactly like everybody else would do it. I think, well, that's a good idea, I'll do that instead of that. Nothing wrong with 01 steel. Nothing wrong with not doing a partial bainite. I just think, do you know what, I'm going to do it like this. Okay, so what the next thing would be is, why do I take those sections out there? Well, I've considered it, and the steel is got a sort of like vacant void in it, but it's not any thinner any way along there than it is. It's not like cutting jagged, it's smooth and got rounded corners. And we've even rationalized where it goes around the center pin. See how it keeps with the shape, all right? It's still pretty strong, but I got 5-6 mil there on a 4.7 mil blank. So I haven't gone to 3 millimeters close to the edge on a 4.7 millimeter thing. My buddy Duncan, he's pushed it to the limit, all right? Look how light that would be. Okay, but there's nowhere there any sort of real less than sort of 2.5 mil on a 2.5 mil blank. Clever, isn't it? So you have a look. His holes there aren't really very close together. They're not actually encroaching on each other too much, because he gives himself options. He's removed steel, but he hasn't randomly got holes drilled. Just my fault. So I hope that helps. Not from my 6 blade out. See you on the next one. Hope that's helped someone. But don't randomly drill holes. I think I'll show that. And if you're a keyboard ninja, there's this thing out there. It's called a search engine.